It seems every course, pure math course that I teach includes lines, even at the college level, it seems. And this is no different. The language here is a little bit more complicated sometimes, but it's still the same thing. We're just looking at good old-fashioned y equals mx plus b. Now, the first thing we've done here is that this is a function. If we drew a line, it's going to pass the vertical line test. So we can replace y with the fancy notation f of x, but it is still just y. Don't forget, that still represents y, just meant that it is a function. Oh yeah, so if in case you need a refresher here, remember represents the slope and b is where you hit the y line. So if I had f of x equals 3x plus 2, you remember the 2 represents it hits the y line at 2, the y-axis at 2. So then what's in front of the x is the slope. We go up 3 in this case over 1 to make another line, up 3 over 1. So this is the slope-intercept form of a line. And what it does is it gives you everything you need to just immediately begin building the line. So you've got the y-intercept, you can use the slope to go the up and the over. Okay, now this question is asking us to take this function here, which is about pressure and depth, and turn it into regular words. I actually don't like the way they described it. I'm going to tell you more like how I would do this in the stats course, and I think in any applied course this is the way to go. So first of all, this fancy language is saying that pressure is a function of the depth. Okay? So pressure is a function of depth, which is what we've learned in the function section previously. Now, what is this saying? Well, let's take a look at the slope. That's where the real important part is. Now, normally a slope is the change in the y over the change in the x. But in this case, we've changed the language a little bit. And we have the change in pressure over the change in the depth. Now, this is how you would interpret this slope here in any real applied course. What we really have here is 0.434 over 1, right? If I wanted to turn this into a slope. And so what we're saying in terms of pressure and depth is this. As depth changes by 1, we can expect the pressure, now it's a positive, to go up by 0.434. So that's what this slope means, and I think this has a lot more value than what they do, just restating this here. So again, y in this case is pressure, x in this case is depth. And so what you'd always do is put this decimal over 1. And now what does it mean? It means, well, as the depth changes by 1, the pressure is going to go up because it's a positive slope by 0.434. Okay? And we could say something here about the initial value. When the depth is 0, our initial pressure is 14.696. So I'm telling you about the slope, and I'm also telling you what this y-intercept it means. When the depth is 0, meaning all of this part, this would drop out, then our initial pressure is 14.696. Okay, just a quick refresher. Do you remember? We always go left to right. So if you have a positive slope, you're going up the hill. So if you were going left to right, a positive slope, you were driving along that line, you're going up that way. If you're coming left to right, you'd be going down the line. Of course, this is constant. You're not changing. You're just going straight across. So increasing functions have a positive slope. Decreasing functions have a negative slope. And then constant functions have no slope at all. That part all drops out, and you just have, for instance, like y is b gives you a horizontal line. Well, so does f of x equals b. Same thing. Okay. Now they're telling us teenager sends 60 texts per day, and they're going to vary the story a little bit and ask us to make 3 equations for a line. Okay, so if it's 60 texts per day, we want to make that a function just based off what they've said here. So here's our first one. Oh, they've gone a little quick here, but so x is the number of days. So this is the total text is a function of the number of days. Well, if it's 60 per day, then 60 becomes our slope. We would just multiply the 60 times the number of days. And that's our total number of texts that this teenager sent. Now, in the second one, what they say is there's a limit of 500 texts per month. Okay, well, it's still 60 per day, but that is being taken away from the total here. So I've got 500 minus the number of texts that are being sent each day, because we can run out. We can get to the point where they're all gone. Now, this would be decreasing. So because we have a negative slope here, the number of remaining texts is decreasing every day. So we're going downhill. So uphill on this first one, downhill. Okay, now they're saying that this is an unlimited plan. It's simply $50 per month in order to do this. So it doesn't matter how many texts are sent per day. It doesn't have anything to do with it. We just simply have to pay the $50. And that's the total cost, no slope, so a constant function. Okay, now I'm sure you've seen this probably multiple times in your past. This is just the formula for calculating the slope if you have 2 points, y2 minus y1, x2 minus x1. The only reason students would struggle with this, or I guess there's two, if you have a negative point on the x1 or y1, just remember there's 2 negatives in a row make a positive. I don't see this very much, but it does happen. Sometimes students will mix the x value from the first point and the y value from the second. That would also mess you up. But most people aren't going to have much trouble with this. So here's an example. Here are my 2 points. I want the slope. So I take my 2 y's. I'm going to use this as y1 minus y2. Now this is the one issue. I've got 2 negatives in a row. That makes it a positive. And I've got an x, my second x minus my first x, and I get this slope. So just be careful of this. That created 2 negatives in a row. So my slope is 3/5. Okay, let's do this again, or you can try it yourself. I'm taking my second y minus my first one over my second x minus my first one. Just stay consistent there and you'll be all right. What do I get here? I get 1 over negative 2. Now remember, with a fraction, I can write this 3 ways and they're all equivalent. So if you were making a line with this slope, you could use this in either way. The negative could be thought of as you're going. So in this case, you could think of this as going 1 up, 2 to the left. In this case, you could think of it going down 1, 2 to the right. It's going to build the same line. All right, they're just giving us the story of slope in terms of a real-life application. So, yeah, so they're telling us these are our x's. As we change years, so we get a different population. So population is dependent upon the year. Does that make sense? So my only point here is that it might be hard to decide whether what's the x and what's the y. Well, the year is telling the story. The y is the population is responding. So if this is the independent variable, this is the dependent, so this is the x and this is the y. Now, what they're doing here is they're simply giving us change in y over change in x. We're finding the slope. So they've done this kind of in pieces here, but so here's the change in the y's, and the change in years is 4 years. So they did the slope formula. That's all they did. Change in y's over the change in x's, and they reduced it down. So population is changing by about 1,100 per year. Okay, so if I wanted to write an equation for this linear function, and I have no points, but they've given me the graph, what I need to do is, well, there's a couple ways to do it, and let's start with this one. They've told me the value of b. It's right there. So remember, b is the y-intercept. Well, it's 2. They've given it to me right there. It's 2. So I have b, and so far I have this. Oh, well, I need my slope as well. So let's find another point where we intersect. So I have 2 points from this graph that are clearly points where it hits an intersection. Now I'm going to find my slope from this. So the scale is a little weird here, but I'm going up 2, 4, 6, and over 2. So my slope is the change in y's over the change in the x's. And again, it's confusing on this picture, but so I'm really going up 2, 4, 6. So my change in y's are 6. And my change in my x's is to the right 2. So 6 over 2 or 3 over 1 is my slope. Well, I have everything I need. Well, y equals 3x plus 2. Now we should put this in terms of function language. Okay, what do they want here? Okay, now this is common when you start, especially if you are a business major, you're going to see lots of problems about linear relationships in the business world. So we're trying to make a function here of cost where it depends, where x is per item. So here's what they're telling us. There's a fixed cost. The fixed cost means it has nothing to do with the slope, it has nothing to do with x. There's just a flat cost every time. This is the y-intercept. And this number here is changing per item. Well, if you have a number changing per item, you've got a slope. So this is the slope because it's changing per. Here is the fixed cost. And if you add those two things together, you'd get the cost. So fixed cost, changing cost, multiply that together, you've got the equation for your line. So right here. Now they wrote it the other way around, which I don't particularly like. I would keep it in the y equals mx plus b form. Okay, now you've done this too. Now you may not remember here. This fancy language looks really intimidating, but all it means is this. When you put 3 into the function, you get a y of 2. When you put 8 into the function, you get a y of 1. That's it. It's just 2 points. Now, if you want to find the value of an equation, you have 2 points. First of all, let's find the slope. So I'm just doing what we did before, y2 minus y1, x2 minus x1. Okay, now I've got my slope. Now, what's different here is that I don't have the value of the y-intercept, but I need to find it. So there's a point slope version of this equation which you might be familiar with, maybe have memorized. I think this is the easiest way to do it. Y equals 3/5 x plus b. Now we have a couple of points. Let's just put one of those points in and solve for b, and then we'll have it. Oh, they're using the point slope form. So I'm going to plug this in. I'm going to use this one. Doesn't matter. You'll get to the same place either way. So I get -2 equals 3/5 when I put in a 3. I've just plugged that x and that y value in. Now I've got -2 equals 9/5 plus b. I'm going to solve for b by just solving that, moving that to the other side. Okay, what is -2 here? I'm going to make it -10 over 5 so they have a common denominator. So this is a more complicated one than you'd normally see, but I get -19 over 5 is b. Okay, well I now have everything I need. I have the slope, I have the y-intercept, and I'm all set. So just don't forget, so you solve for b using the point they gave you. Either one, doesn't matter. Now once you have b, don't forget to go back and make the equation, because that's what the original question was asking. Now it's asking linear function, so I should be changing this to use the function notation. Okay, same thing. Feel free to try this if you want to. But what I've got here is these points, 2, -11, and 4, -25. All right, let's just do the slope. y2 minus y1 over x2 minus x1. So I've got the double negative here, so this is really -25 plus 11 over 4 minus 2. So I get a slope of -7. Okay, I've got a slope. What I don't have is the y-intercept. Let's use either one of these points. Solving this, I'm going to get b as 3. So I've got So I built my final equation, and I went ahead and changed it. We're talking about functions, so I'm going to put that function language and replace a y. All right, they're asking us to make another linear equation out of this story. So he's got a flat 200 songs in his collection. So that's the number that's not changing. 15 are changing every month. This is the changing number. That, if it's the changing number, that makes it the slope. So they've done this pretty well here for us. So if I just had normal function notation, I've got this changing number as my slope. He already has 200 songs. So every month this is changing. So they've written this. I'm more comfortable with this notation. You probably are too. But what they've changed this is to number of songs is a function of time and months. So this is a little confusing because we feel more comfortable with this, but it's the same thing. I wouldn't have had any trouble with you just leaving it like this, or 15x. Okay, oh, they asked us to predict what would happen in 1 year. Well, this was per month, so we need months, so we'd put in 12. We think he's going to have 380 songs in a month. Okay, this one again is asking us to find a line, but what they've done now is they've given us 2 points hidden in a story. So 3 policies, he gets $760. 5 policies, he gets $920. So they've just given us everything we need to do we've got to find the slope and then find the equation. We've already done it. This is just hidden before in a story. So we've done the same type of problem. We've got y2 minus y1, x2 minus x1. I found the slope. It's 80. Okay, now once I have the slope, now they're using fancy language here, but I have the slope, so I would feel more comfortable with just doing it like this. Now, we're trying to solve for b. We don't know the intercept. Well, let's put in a point. The point is 760. So we put that in, solve for b, we get 520. So we have that y-intercept, and there's our equation. Now, again, they're using fancy language here. I would be fine with. Okay, now I think this is the last type of problem we're going to see. They're asking us to tell this story. Here's my x's, here's my y's. Something about rat population, but here's the key. I have 2 points. I could use any 2 points I want. But what's going to make this a little easier is if I have x of 0, then this is all of this here is the y-intercept. I have it. So I know b is 1,000. So let's see. So yeah, so let me jump ahead here a little bit. So they used 2 points just to find the slope. You could use any 2 points that you want. They found the slope is 40 just by using the equation for the slope. Well, I also have b. I know the initial value, which is what b is 1,000. So I've got the slope, I've got the initial value, I've got everything. I don't know where they put the equation. Oh, it's right here. So there's my slope, there was my initial. Okay, so one more of these here. Same thing. Do you see I instantly know the value of b is 12.5. Now, I'm not going to do this longhand, but you see the change in y's here between these 2 points are 1. The change in x's are 2. So my slope is change in 1 over change in 2. So my slope is 1/2. So, okay, they want this, yeah, I guess I'll do it. They wanted this to be about height or something. I didn't even read it. But my slope is 1/2, and my intercept is 12.5. Okay, so it's all the same line stuff you've seen before. The only thing that's different is we've put it into a more complicated, more mature language, but it's all the same stuff.